All right, and welcome back to our fifth and final week. I cannot believe that class is already ending. Awesome job. You rocked your midterms. You've kept up on the ARQs and the discussions and everything. So looking forward to reading your papers this week. A few of you have turned them in already. Make sure you get those in. Those are your letter to your representative papers. This week we're going to be talking all about literacy, math, social studies, and science, just ways to teach it. We'll jump into that right after this. You have a discussion on civics education, you have a couple ARQs due, and then your final. We'll do a little final review at the end of this video as well. So great job. I hope you enjoyed the class. I know 5 weeks to get through an entire textbook feels like a lot, but you've all been able to do it. So great job. I hope you've enjoyed this style, this YouTube lecture and those daily assignments, and it's kept you engaged. Really enjoyed meeting all of you and answering your questions and hearing from you and reading all of your papers. So if you liked this class, let me know. If you didn't like this class, let me know what I can do to change it. There's a evaluation to fill out. Please do fill that out. That helps me learn how to teach differently or learn what you enjoyed. So with that, we're going to jump into this chapter, and hope you have a wonderful rest of your summer. All right, so for this module, we're going to be talking about literacy development. So we'll look at reading and we'll also look at writing. If you're following along in the PowerPoint, you're going to see the 6 things we're going to cover, looking at phonics and phonemes, why and how we develop vocabulary, best ways to teach reading comprehension, and some trends in emerging writing skills. So why should we care about literacy? What's so important about literacy? Well, you need it to be able to get a job and really excel in the working world. Literacy opens a ton of opportunities for self-improvement, for learning, for finding ways to help yourself manage whatever might come up in your life. And also, literacy is really important for society. Being able to stay informed and participate in democracy, that really requires that children learn the fundamentals of reading and writing. So literacy is super important. Let's get into it. A lot of children fail to adequately meet the standards for reading, whether it's due to lack of exposure to books or bad instruction or a number of different things. And so it's important to be able to catch that and figure out how to correct it. In Colorado, you can track proficiency in reading by looking at the READ Act report. And if you're following along in the slides, I have some data and really what that looks like in a colorful table. There's been a lot of research that's examined the development of reading and writing, and a couple big things have come from that. We learn what the skills of reading and writing are, we learn what developmental trends are typically observed, and we learn about the best practices for teaching literacy. So over the next couple slides, we're going to go over those 3 big ideas. Looking at literacy, it starts before we even learn how to read. It starts when we learn how to talk, because we're learning the sounds of the language that we speak, and that's what we use for reading and writing. In the preschool years, we learn how to connect those sounds with letters, like learning A would sound like ah. Children really learn how to write those letters before they can actually reliably read them. Learning to read and learning to write are really an interconnected process, and actually writing precedes reading oftentimes. So we're going to talk about the 5 aspects of learning to read. We have phonemic awareness, phonics, vocabulary, fluency, and finally text comprehension. Phonemic awareness, let's start there. It's the ability to notice and to work with the individual sounds that make up a word. In a language like English, learning to read requires a masterful appreciation of the individual sound units that make up our language. Studies show that phonemic awareness is actually one of the best predictors of later learning abilities. So it's important to do whatever we can to develop this skill in our students. Really, the most effective way to teach phonemic awareness is to teach it along with letter naming. A, ah, apple. Let's talk about phonics. Phonics entails teaching children to connect the sound of language, which are phonemes, with the symbol of language, which are graphemes. Mastery of phonics enables children to do a couple of different things. We can decode words on a page, C, A, T, K, A, T, cat. And we can figure out how to write words down. So if we want to write about that pet cat, now we know. This is also related to the idea of an alphabetic code, which is just that the system that children are essentially figuring out when they're learning to read. What is fluency? Fluency is our ability to read things smoothly. If you click on Reading 1 under Modules, you'll see an example of smooth versus choppy reading with Brown Bear, Brown Bear. And really, fluency is being able to follow along and read out loud and in your head smoothly. Next thing we're going to talk about is vocabulary. Vocabulary is so crucial to reading. Without knowing the meaning of words, we're simply making sounds aloud or in our minds. This is what would happen if you sounded out words in a language you don't speak, but you do know the letters of. For example, if you could read English, you could probably sound out German, French, Italian, or Icelandic, but there's not a ton of meaning there because you don't know that vocabulary. The simplest level of extracting meaning from text is knowing what a word means. So, the more words that we know, the better we're going to be able to understand our text. So how do people learn words and learn word meanings? Well, most of it happens informally. Not because adults are trying to teach them in the moment, but some of it does happen intentionally, like if you ever had a vocabulary test in one of your classes. When you look at reading number 1 on your modules, you'll see some tips of what to practice for formal instruction and informal instruction with language development. This is really important for you to talk with your students' parents about. The last thing we're going to talk about is reading comprehension. And this is really important to developing the ability to extract meaning from text. Some people talk about this distinction between early reading instruction and learning to read and versus reading to learn. So reading comprehension really requires that the reader is actively thinking during their reading and reading with real intention. That's like our ARQs. It's asking you these deeper meaning questions. It's asking you to make connections in your real life to the reading. That's reading comprehension. Next, we're going to talk about learning how to write. So emergent writing, if you're following along in the slides, I have some examples here. Learning to write begins well before elementary school. If you look at this table on the right, you can see some examples, and if you go in the modules from reading number 2, you'll see some pre-writing. So you'll see drawing, and it's just scribbling, like making lines on the page, then scribbling, like intentional scribbling, made kind of like trying to copy, then doing some mock handwriting, then maybe some mock letters and some letter strings, and eventually it gets into the writing that we have today. So when we're learning to write, 3 things are really important: conceptual, procedural, and generative. Conceptual is the functions or the purpose of writing. Do you know what writing is for, what it does? Procedural then is the practical components of forming those symbols on the page and knowing what letters to make. And finally, generative is the capacity to think of ideas to convey in print. This could be like story ideas, lists, or any kind of sentence that communicates meaningful information. If you want, you don't have to, but in your modules, you can contribute to this writing class gallery. You can add samples from your childhood work or models from your students or your children, and you can share the age of the creator. If you want to participate in this, not worth any points, so you don't have to, then you can talk about other people's submissions. What stage do you think the writer was in? And was it conceptual or procedural? Becoming a skilled writer takes a couple of things. You have to be fluid at adeptly using proper spelling, grammar, and handwriting. Fortunately, we have programs like Grammarly that can help us out with this, but you need to lay those foundational skills. We want to master writing for different purposes. We want to be able to self-direct our writing project work and really our attitude. We want to have a positive attitude towards writing. If you go to reading number 3 in your mods, you'll see some details about skills and how to develop them. And that is all we're going to do for this first mod on literacy. Let's jump into mathematics. All right, so our next topic is math, and we have really 4 big ideas here. We're going to talk about the 4 math-related characteristics students should have when they graduate. We're going to differentiate between 3 different types of knowledge that are important for math. We'll describe the best ways to teach math, as well as the development throughout elementary and middle school. So these are the 4 characteristics your students should have when they graduate. The first is to think of math as meaningful and goal-directed, and how it can help them in the real world. So think about math is more than just numbers, but how can I apply this to my life? Next, students should have efficiency and flexibility in their problem solving. So they need to know how to use their math facts and their procedures and their concepts and how to put that all together to generate real-world situations and solve real-world problems. Third, we want our students to be able to demonstrate adaptive mathematical behaviors and beliefs. So we're really just looking at our students feeling good about their ability to solve math problems and being able to apply that to their world. And finally, we want to equip our students with the knowledge to solve a wide range of problems. And from that, we'll talk about 3 forms of math knowledge. The 3 forms of math knowledge are declarative, procedural, and conceptual. Declarative is really just a person's knowledge of math facts. 2 plus 4, that equals 6. I know that. Procedural is knowledge of how to solve a math problem. So that would be knowing like a strategy, like the min strategy. 3 plus 2, you go 3. 4, 5. That'd be procedural. And finally, conceptual, just knowing what the math really means. Understanding what M means. As you read through your book, try and understand why all 3 of those is important and really think about it. Why is it important to be able to look at something quickly and just know the answer to it? Why is it important to be able to use the strategies you've learned? For conceptual knowledge, it's really important for a couple different reasons. It allows our students to solve the most novel of problems. It enhances our memory. It increases our intrinsic motivation, and it increases our self-efficacy. If our child understands the concepts behind the lesson, then they'll be able to apply them in the future. It's much easier to remember information that we truly understand rather than just staring at it, not comprehending it, and spitting it back out on a test. So now we're going to talk about the development of math skills. In preschool, we're starting with a knowledge of numbers, counting. This is a big part of it. And you'll see these 5 principles if you're following along on slide 8. One-to-one, stable order, cardinal, abstraction, and order irrelevant. And so one-to-one is just that each item is only associated with one number. So if you have 10 candies, you don't just go 1, 2, 3, 4, 5. You're going 1 candy, 2 candy, 3 candy. That's one-to-one correspondence. Then we have our stable number principle, which really just says number names must be in a stable, repeatable order. 1, 2, 3. We don't want to go 1, 11, 74. We want to keep them in their order. We have the cardinal principle, which is final numbers in a series represent the quantity, the entire quantity of the set. Then we have the abstraction principle, which just says all 3 of those apply to any and everything. And finally, order irrelevant. It doesn't matter what order you're counting in, the things are still going to be in the same order. So if I start counting my candies from left to right or right to left, still going to be 10 of them. So let's talk about development in elementary school. So I have 6 strategies for solving addition problems here. Count all, count on from first, count from second, count from the larger, derived facts, and direct retrieval. And basically what we're looking at with each of these is we're counting and adding on, and depending on where we start. With derived facts, we use our known facts to construct the answer. So let's see, 3 plus 3 is 6, and so 4 more would be 10, because I knew 3 plus 3 was 6. And then direct retrieval is just memorizing those addition and subtraction and multiplication signs and just knowing the facts. I see 4 plus 2, I know it's always 6, so I don't need to count. The next part of this chapter talks about decontextualized problems. And so we're teaching our children how to decode the sentence where each part has a value. So we would take away addition and subtraction because that would make our students just memorize the symbols without understanding the purpose. So instead, we'd want to do something like a word problem. Julia has 3 cookies. Tommy gives her 5 more. How many does she have altogether? That's our word problem. That minus sign is gone, that addition sign is gone. And so there's a couple steps to solving these word problems. The situational model says construct a mental model of the information given. So we could draw that. Julie has 3, Tommy has 5, and draw that. Here's 1, 2, 3, 1, 2, 3, 4, 5. Then we have our semantic structure. And this just says understand what is the problem asking. Is it saying, did he take cookies away? Is it saying, did he give her cookies? We're wondering, did he increase, decrease? What's going on? And finally, understand what operations you need to do to get the results based on the information. And so I would say, okay, he gave her some cookies. I know that addition is plus. That must be what it is. And so now we've created our own math equation from this word problem. The next part of math that's really important is schemas. This comes up a lot in elementary math. We have part-whole schemas and word problem schemas. And so part-whole schemas is just the knowledge that a given number is actually made up of multiple parts. There's many ways to make up a number, and it's nonlinear problem solving that's occurring. So an example, the number 3 can be made up by 0 plus 3, 2 plus 1, 1 plus 2. And so when we're solving problems in a linear way, before we have this, we'd say 1 plus 2 equals 3, and 2 plus 1 still equals 3. With word problem schema, we have problem schema, action schema, and a link between the two. Problem schema is really just the understanding of what each type of word problem is looking for. Action schema is just solutions to each word problem. So let's move into the development of math skills in middle school. We want to learn about rational numbers like fractions and decimals, and integers like whole and negative numbers. This can be really hard to understand, and it's because those concepts are just more abstract. And so teachers don't often spend a lot of time teaching conceptual knowledge, and that's what can make this really challenging and make it even harder to learn these problems. If you have a student who's had conceptual knowledge of fractions and integers before formal instruction, then they're going to do a lot better than your students who have had less conceptual knowledge. Teaching whole numbers and fractions at the same time could improve later performance as well. When we're looking at instructional implications, we want to structure our teaching in ways to enhance children's existing math knowledge. So those counting principles should be the first focus, and then really just increasing number familiarity. Conceptual understanding is so important. Like I said, a lot of times in middle school it gets brushed over, so make sure you're covering that. And just promoting metacognition skills in solving math problems. Share out with peers. Have your students, okay, Johnny, come up and share how you got that answer, and let other students see that. And that's all we're going to do for math. All right, so let's do our last mod for the entire class, and it's science and social studies. And so what is science, and what is scientific thinking? And so scientific thinking is really just knowledge seeking. It occurs when we update our theories based on new information. This can be formal or informal. So formal scientific thinking develops over the course of childhood and adolescence and through instruction and practice. But informal scientific thinking seems to happen automatically and with a high frequency in early childhood, as the child starts to generate explanations for the underlying principles of how things work. This is why children often have misconceptions. So science is not a fact to memorize, it's a process. The foundations of scientific thinking emerge during the early preschool years. And it's where we distinguish beliefs from reality. So we want to be able to coordinate theories and evidence, and we really need to appreciate that what we're thinking in our mind is just a representation of an object or an idea. So my representations might be incorrect, or they might be different than other people's. In the preschool years, children come to understand that belief can be false and that beliefs can differ between two people presented the same information. So the next concept is indeterminacy. And this is a major shift in thinking that occurs during preschool years, and it's the emergence of the ability to evaluate indeterminacy. And that's the state in which the possible explanation is not fully clear from the available evidence. So I don't know enough to figure it out, and that's where I am. Children start to be able to identify indeterminate versus determinate situations in their preschool years. Another major shift is identifying the source of information. So this can also happen in the preschool years, and it's that children start to develop the ability to monitor how they learn information. Younger children tend to know information, but really struggle with identifying how they learn it. Did I experience that, or did I always know it, or did somebody tell me? And so big improvements are observed in this skill between the ages of about 3 to 5, and we're not fully there until about middle childhood. So knowing the source of the information is really key. It gives us clues out to how reliable that information is, and if we should really make our conclusions based on it. We're going to talk about 4 phases in scientific thinking: inquiry, analysis, inference, and then argument. So let's start with inquiry. This is setting our intentions. We're going to decide what is my goal and what am I going to try and achieve from this goal. Mature scientific thinkers are able to recognize that the data set they have can reveal the answer to the question. So the data set would be, this is the example I have in the PowerPoint, a set of behavioral observations of how dogs react when a human points. And the answer might be, do dogs understand the meaning of pointing? In this phase, it's really crucial that the individual note that the evidence they have is distinct from the theory. So the list of data findings is distinct from dogs understanding the meaning of humans pointing. Next, we're going to move into the analysis phase. And in this phase, we have to parse out the data available, and we need to really mentally represent it. Then we're going to move to inference. In the inference phase, we're drawing conclusions. What do I know and how do I know it? We tend to see a lot of errors occur here because thinkers are drawing conclusions from data that are not warranted based on our available data. A common issue is that if we're presented with evidence that is consistent with our theory, we consider it supported. And we're actually trying to disprove our theory. So this is just like confirmation bias. If I go, wow, Comcast is the worst, and I Google, why is Comcast so bad? Probably not going to find anything that tells me why Comcast is good, just things supporting. So I really want to search for problems with Comcast or why Comcast is the best, and to see, is that going to change my mind or support my theory? Argumentation is the final stage of scientific thinking, and it's being able to support your claims in an argument. Articulating claims really helps you grow in your thinking. If we think back to Vygotsky and the role of language in cognitive development, that might support this a little bit. This kind of thinking can also apply in different situations, so developing scientific thinking skills really helps with critical thinking. Next part of this chapter is mental models, and the mental models that thinkers have for cause and effect and other aspects of scientific thinking have a huge impact on their ultimate interpretation of the situation. So, for example, if a student has a mental model that there is one cause for an outcome, they are likely to stop looking for the contribution of various factors after they've identified something that might influence their outcome. Every time I wear my blue socks, I win my basketball game. That's it. That's my mental model. My blue socks are the reason I'm winning my game. I'm not thinking maybe I should practice more. Maybe we're getting better. Maybe my passing is better because I've been working. Nope, the blue socks. And so that's a stuck mindset with that mental model. Another part of this chapter I want to talk about is metacognition. And so, when engaging in scientific thinking, there are a number of steps along the way when metacognition comes into play. So, one example is one must think about one's own thinking process when setting intentions for inquiry, deciding on a strategy for analysis, and evaluating whether our claim can be supported by our evidence. So, in addition to teaching the steps in the scientific method, we also want to teach children about the why behind solving those problems. I have a reflection question here. Just think back to your own science education when you were a K through 12 student. What were some memorable experiences that stand out to you? What aspects of scientific thinking were your teachers likely trying to get you to practice? And just think about that. In my own practice, I try and bring in science into the social emotional world because I just feel like it makes more connections. Like we'll fill a bag up with vinegar and baking soda and shake it and talk about what happens when your feelings are kept inside and the bag pops. Talking about, well, we don't physically blow up, but maybe we yell or scream or get really upset. So I like to tie that in. And so think about ways that you can tie in different parts of science into your lessons. Next part of this chapter is social studies. Social studies is what? It's not super well defined. In general, it's this umbrella term, which includes geography, history, civics, economics, sometimes psychology, some political science. So it's very broad. Why do we need to teach social studies? A main reason is it's thought to be important for preparing children and adolescents to become members of a democratic society so that they can vote on issues and candidates based on a reasonable understanding of how the world works. Another aim is to teach children to think in terms of social sciences. So we want to know how to look at evidence and draw conclusions about the economy or different psychological phenomena. So how do we teach it? We want to use best practice for teaching of all of our subjects. And while you're reading through this chapter, you're going to see a list of 8 recommendations that can tie back into the content we've been covering all semester. You'll notice the importance of scaffolding and connections, and think about how that can be tied into social sciences. Finally, I just want you to think back on your own social studies education and just what were some memorable experiences. And that's really it for social studies. So I'm going to jump into a little bit of final review. Otherwise, if you've made it this far in the video, great job. And I hope you have a wonderful, wonderful rest of your summer. You made it to the final review. Awesome job. I know you're going to do great on this final. Thinking about if I was taking the final, what were things that I would want to definitely know and definitely study? I think I'd want to know how you could apply motivation to enhancing your students' learning. I'd want to know, like, if you were a teacher, what actions would you take? And what are the principles of motivation and how would you do it? I'd probably want to know a lot about self-regulated learning and thinking about what kind of advice I would give someone to do self-regulated learning. I'd want to know how to create effective context for learning for students. I'd want to know what the term phonics means and explain why it's so important to literacy development. I think I'd want to know, why do people have trouble changing their minds even when they have scientific evidence that contradicts what they think? And it'd probably also be important to know why conceptual knowledge is so important in math. And how does it even help students answer word problems? If I was taking this test, those would be big ideas I'd probably want to know. I'd want to know about what's important for children to develop fluency in reading. I'd want to know what phonemic awareness was. I'd want to know if families, schools, churches, and workplaces were considered a culture or a civic engagement or a society or even a community social capital. I'd want to know the difference between a fixed and a growth mindset and intrinsic and extrinsic motivation. I know you're going to do great on this final. Have a wonderful, wonderful end of class. Enjoy your last few days before you start up in the fall. If you're graduating, congratulations. If you're taking a break, also congratulations. I hope you've enjoyed this class. Please send me a message and let me know what you thought, and hopefully you enjoyed it. Bye.